Okay, for today's notes, we're going to look at conditional probability. So conditional probability, we're going to do a little warm-up here. And I want you to consider that a bag has one red marble, one white marble, and one blue marble. So basically you've got one of each. Okay, so with that in mind, what's the probability that I draw one red marble? Well, in this case, you just have 1 out of 3, right? So I could say if you wanted, right, a 1 out of 3 is a 0.333 repeating, so like a 33% chance of getting one red marble. However, how is this different? What is the probability that I draw one red marble given I already drew out a blue marble and didn't replace it? So remember from last time, if I draw out a blue marble and I haven't put it back, I now only have 2 marbles, and one of those is red. So that's going to be a 0.5, which as we convert that to a percent, we would get 50%. So the notation we'd use for something like this is P for probability of red. That line means given blue. Means the probability of drawing a red given that we already drew a blue. So in general, we'll have some event A. So probability of A given event B. The probability of event A happening given that another event B has already occurred is known as the conditional probability. So if we look at this Venn diagram below, it shows a response of 500 seniors, we'll say, at Corner Canyon High School. That were surveyed. And we want to find the probability of each of these. So what's the probability that a senior would be male? So in this case, for males, we've got 105 and 135 when we look at the entire circle out of 500. So we have 240 out of 500 people, out of those 500 seniors that are male. If I change it slightly, then I say if a randomly selected senior is male, now, rather than just looking at the whole table, I'm just looking at the males, right? I'm just saying if they are male, what is the probability they have a job? So the job is in the middle there. So in that case, you've got 135 out of the total males, which is 105 plus 135. So that's 135 out of 240. Versus if I change things up a little bit and I say, okay, what's the probability that a senior is a male given they have a job? The given statement here this time is that they have a job, right? And so if they have a job, the amount of people that are, in this case, that are males is the 135. So 135, but this time out of 135 plus 165. So we have 135 out of 300. Okay. In general with these ones, I would just pay attention to what it says, like, so if a randomly selected person is a male, we're just looking at that group of people. Let me read you that real quick. Okay. Right? Or given they have a job. So we're looking at just one kind of part of it. So we're going to do some more. We got two-way tables here. Use the two-way table of what people ordered at a concession stand to find the probabilities of a randomly selected person. So what's the probability that a person ordered a hot dog? So in this case, there's 158 out of a total of 400 people that ordered. What is the probability the person ordered a pizza or a soda? So remember that, pizza or soda, it could be either of these two categories. So we've got 182 that ordered pizza and 200 that ordered soda, but you got to remember we double counted the 120, so to take that off out of the 400. So 182 plus 200 minus 120, we get 262 out of 400. Okay, now we've got some conditional things. What is the probability they got a water if the person selected ordered no food? So in this case, we're just looking at the people who ordered no food. So we're looking just at this row. and we want the probability they got a water. There was 20 people who ordered a water but did not get any food out of the 60. Okay, so you can think about this as over the total of no food. Whereas this one, when it says, hey, given they ordered a pizza, we're just looking at the total of people who got pizzas. So in this case, we're looking at the total of 182, and the probability they got no drink, there's only 4 out of 182. Okay. We're going to continue to do this. I changed up the notation and kind of did it in terms of the probabilities around the words. In general here, though, whenever you get a two-way table, the first thing I would kind of do is find the totals. Even if it doesn't ask for it, I think it will make your life a little bit easier as you go through if we know what the totals are. So go ahead and add across. You're like, hey, 9 plus 12 plus 16 plus 14, we get 51, right? 11 plus 4 plus 16 plus 15, we have a total of 46. 10 plus 12 plus 18 plus 15, we've got 55, which means our overall total here, 51 plus 46 plus 55, we surveyed 152 ice creams. Okay, if I go the other way, we've got a total of 20. If I add down that for chocolate, 12 plus 4 plus 4, 12 plus 4 plus 12, we get 28. 16 plus 16 plus 18, we get 50. 14 plus 15 plus 15 is 44. And if you add across that bottom, so 20 plus 28 plus 50 plus 44, I got, oh sorry, this first one was 30, my bad. We also get 152. Okay, so if we just want the probability that someone chose chocolate, we've got a total, or sorry, vanilla, we got a total of 30 out of 152. But notice this one, think about this as like, hey, the way I kind of think about read this notation is the probability that they have sprinkles. So it's sprinkles given they have vanilla. So in the denominator here, think about the vanilla going. So as we think about this, we're just looking at people who have vanilla, which is 30. Those people who also got sprinkles is 9 out of 30. So we're just looking at the vanilla here. So maybe I'll even write that. Think of as divide sign. So, oh, maybe I should write that a little bit differently, sorry. Given. Think of as divide sign. So vanilla on the denominator or bottom of the fraction, right? Okay. As we look at this next one, we're just looking at over the hot fudge. So our hot fudge in this case is a total of 46, right? So that's going to go in the denominator. And we're looking at those who got mint chips. There's 15 out of 46. When I look at something like this next one, hot fudge and, union, which is or, chocolate. Remember that's the one where you have to look at both. We're looking at hot fudge, which is 46. And we've got chocolate, which is 28. Remember, you got to subtract the overlap all over the total. So 46 plus 28 minus 4 is 70 out of 152. Okay, hot fudge intersects, so and chocolate. So in this case, we're just looking for the overlap of hot fudge and chocolate, which there's 4 people who did that, or 4 orders that did that, out of the 152. Okay, something I maybe would go back and add in our notes up here maybe is our denominator. I guess you should know our denominator changes, right? So it's something to kind of point out. Okay, one last one. This time I got a Venn diagram. The Venn diagram represents the languages a group of 105 people speak. And we've got S is the event that the person speaks Spanish, C is the event that the person speaks Chinese, and E is the event that the person speaks English. Okay, so as we look at this first one where it says the probability of Spanish given Chinese, we're looking at Spanish given Chinese. So we're looking just at the Chinese group and we're saying how many of those people do Spanish, right? So we're just focusing on this one circle. So if I focus on that one circle, I've got 3 plus 8 that do Spanish out of the total Chinese, which is 3 plus 8 plus 2 plus 13. So maybe I'll do that kind of on the side. So Chinese is 3 plus 8 plus 2 plus 13. We get a total of 26. So we're going to have 11 out of 26. Okay. As I look at the next one, similar idea, so maybe I'll actually stay in purple. But this time I'm looking at just who does English, which there's 8 and an additional 13, right? It's just these two that have the overlap out of 26. So we get a total of 21 out of 26. Okay, this next one, though, we're looking at who speaks English, given they also speak Spanish. So we're looking just at the Spanish group. So in this case, for Spanish, we've got 7 plus 3 plus 8 plus 33. So that's a total of 51. And those people who speak English is 33 plus 8 out of that 51. So we get 41 out of 51. This one's a little bit different. This is now saying, okay, what's the probability that they speak English given that they also speak Chinese or Spanish? So remember, or we're looking at both of those circles, and then we want to know if they also speak English. So real quick, if we look at Chinese or Spanish, we've got a total of 7 plus 3 plus 8 plus 33 plus 13 plus 2. So as we add all those together, we get a total of 66. So this is going to have 66 on the denominator. As far as the people who speak English, there's now a little bit more overlap, right? We've got all of this who also overlaps the English circle. So as we think about that, we're going to have 3 numbers that we're adding on top. The 33 plus the 8 plus the 13 all over 66. So we get a total of 54 out of 66. Okay,